Hello, everyone. I'm Pablo Apiolazza, and welcome to Perspectives podcast. This is the third episode, and with me we have a fantastic guest. His name is Marco Franzon, and he's an expert in the cloud computing. Let me introduce him properly. Today we will talk about a series of topics that are around generative AI and cloud computing, which is pretty much the base of all computing that is relevant for human life, actually, lately, right? If I'm not wrong. So first of all, I would like to introduce Marco. Marco is a data engineer at Exact Lab, a company specialized in high performance computing. And he's also the co-founder and CTO of Dualistic, which is a new startup from 2023 that specializes in digital twin technology. He has an educational background in biochemistry and data science from the University of Trieste. And he's very keen into MLOps, machine learning, and the transition of ML models from research to production. So, well, without further ado, how are you, Marco? Let me say.
All fine. Thank you to invite me here. I'm very happy to join you in this podcast. Yeah, I think that we have a lot of topics to discuss today, interesting topics. So let's start.
Let's do it. So, okay, let's begin with the most basic things, because this podcast has the objective to get deep into subjects, but starting from the beginning. So, talking about algorithms and processes and everything that makes the world go round today, because software is necessary and critical into every activity of the humankind right now. There's a big difference that has been developing in the last 20 years, I'm guessing 10, 20 years, which is this paradigm between local and cloud computing, right? Can you explain me a little bit about this?
Yeah, so the main difference between local and cloud computing is, I like the statement that cloud is someone else's computer. So the main idea is that when you run something on cloud, you are deploying your application in a service, in another, in a cluster of computers handled by someone else. And instead, yeah, the main difference is that you give the permissions to run your code to someone else, and also you had not to care about the status of the machine. And this is the main thing important for a developer, because if you are the maintainer of the code, 90% of the time you don't want to maintain also the infrastructure. So if you use cloud for this reason, you can avoid to think about, oh yeah, my PC is on failure, so I had to update something or to fix some bug that can take a long time. Instead, if you run on cloud, you have none of this problem. And this is one of the main point why because the cloud has so much hype, and is continues developing.
You work in Exact Lab, which is a company specialized in high performance computing, right? Yeah. So that was something that wasn't as necessary as it wasn't a popular application of cloud computing, right? So I would like to explain to the audience what high performance computing is and what is the difference between like regular computing and this type of computing, and how this is changing right now with these new technologies.
Yeah. So high performance computing is a subset, of computing, which is, regard a certain kind of application. In general, we talk about HPC, so high performance computing, when we consider clusters, so multiple computers connected each other. And this is the fundamental of HPC, because in general, your application had to be handled by multiple PC, because the workload, so the computational time and the computational amount of calculation that you have to do is really huge. So a single computer could not handle this workload. And this is the bottom line of HPC. For the time being, high performance computing becomes relevant because, for example, for machine learning tasks, when you have to train large models, you need to spread the workload on many different machines, because otherwise you cannot handle this large training. So HPC comes fundamentals also for this application. It is born for physical simulation, which requires a lot of computational time, typically, but now it becomes relevant also for machine learning.
This is something interesting because if the paradigm of maybe we're going ahead too much, but we will talk about this later. But the difference between the computing of a regular algorithm and a machine learning algorithm is orders of magnitude more complex, right?
Yeah.
So if all these procedures are becoming machine learning inferences and or trainings, there will be a stress in the network, pretty much in terms of computing, not in terms of traffic necessarily, right?
Yeah.
So how do you consider this in the future? Do you think there will be differences in costs? Are there already differences in cost? How do you calculate these cost differences when developing?
Yeah, this is very important when you plan to design, for example, a new neural network. You have to consider where the neural network runs and which hardware it uses as much. My personal opinion is that the future will be on new hardware. So it means hardware customized for specific tasks. For the time being, we can see, for example, the TPUs, which are a custom hardware that runs just for some machine learning calculation. So this is useful because using this specific hardware, you can reduce the power cost. Instead of using large GPUs, for example, which are more demanding in terms of energy and also cost much in terms of money. So yeah, I think that in the future we had to move not only or to improve the algorithm in terms of logic and software, but also to improve the hardware to have a low impact in terms of energy usage.
Thank you. Can you explain me what are Kubernetes and microservices?
So in the logic of the cloud computing, one of the fundamental software tools, frameworks, we can call it in different way, is Kubernetes. It is by definition an orchestrator of containers. So it is a sort of framework that handles for you a lot of services. Services are just some applications that runs on cloud. the power of this framework is that you can this orchestrator is that you have a central dashboard, a central control plan to handle potentially thousands of services without caring about the control of each one. So Kubernetes has some functionality in its core. For example, it guarantees that each service can run can stay forever in the cluster. So if there is for some reason a failure of the service, Kubernetes itself takes care to restart the service and it is guarantee you that you had not downtime for the service. And this is one of the main it is the selling point of Kubernetes. So the reliance of the service you put into.
Okay, so so pretty much it's correct me if I'm wrong. It's a serverless solution. So you have the computing on one side, and the content, which is the code and the data that is being processed, the input pretty much, on another one, right? So this is a way to scale up or down, and also to like you say, assure continuity of service, pretty much.
Exactly. Yeah. The other selling point for sure is the scaling of the service. If you have a service that has a ton of requests, for example, I can think about the social media, which can be visited by thousands, millions of people in a short frame of time. You have the necessity to scale the service in multiple services, which are the same but replicated in multiple time, that guarantee you the continuity of the service because a service has a limit. So after a certain amount of requests, typically it fails because it cannot handle infinite amount of requests. Yeah.
So when these cloud and microservices systems or solutions are a good idea, and when are they an overkill?
Yeah, at the moment, I see a lot of inappropriate usage of microservice. Sometimes, when you have just a single application, for example, a classical web application, and the usage of this application stay under a certain threshold of requests, typically 1,000 of requests, make it in a serverless mode. So put it for example, in a Kubernetes cluster is for sure an overkill, because you had to handle too much complexity for that not pay you, because it's useless. I mean, if you have the same application deployed in a server, you have the same performances without all the infrastructure, which is for sure a cost that you can avoid. So yeah.
Mm-hmm. Sorry. Yeah, please finish.
No, instead, on the other hand, you had to put your services into a cloud environment. For example, when you have multiple services, many of them, and you had to be sure that there is no failure. So if you have a critical service for that, it has to be up and running 24/7. So a solution like cloud hosting is for sure a good option. For example, in a Kubernetes cluster, because it guarantees this reliability that a server sometimes could not.
So let's say you are developing an app, right?
Yeah.
And you have this, well, of course, for an app, the destiny, if everything goes well, is to end up on a cloud, right? So how is the process when designing an app? Well, not the app itself, but the profitability of the app, to understand how much will it cost to provide a service to the end client when they are triggering an action.
Yeah. In this, I mean, there is different solution to provide an app. To provide an app in general, I mean, I can think of three possible solutions, which is the naive one, which is hosted in a server, and you provide simply by the hosting. Second one is putting the app inside a much more large infrastructure like Kubernetes cluster, for example. And the third one is use a serverless approach, which is a slight different from a Kubernetes cluster. Yeah, because the philosophy of the serverless is that you run just an application, you run just a function, possibly, not a service entire. So the difference is, is very small between service and function and application. Service in general is a little bit much complex because it requires some configuration when you deploy it in a Kubernetes cluster, for example. Instead, an application, a pure application, is literally just the code, and you can upload this code in a serverless service, and it handles for you the runtime of this application. So this is the three possible way you can host an app, a service for a customer.
Okay, so your advice for because with the advent of the GPT and all this revolution of AI, for example, there are millions of applications that could be developed of these technologies. So there's a lot of sandboxing involved into these new potential new services. So your what would be your advice? Start with your own server and make it fail, and then move to the next one.
I think that a good advice is use a mixed approach. At the moment, there are many different services that websites that gives you the possibility to host a serverless application, and I recommend to use them for computational demanding tasks, like, for example, hosting a generative AI model. Instead, the classical, web application part, so the front end and the REST API, could be a good idea locally or in another service, not serverless, because you want that for example, the front end, you want that is always up and running, not stay in idle when you have no request. This is a very interesting point, that in serverless field, when you are not interacting with the application, typically it goes in idle. So it was shut down, and you have to wait another request to start up and restart the process. So I think that this is a good approach. Put the computational on someone else's computer in serverless, and guarantee the web application by your own. Yeah.
Okay, so moving into, since you're talking about the generative AI, I think it's nice to talk about. We talk about infrastructure, so the computers, other people's computers, they are doing our tasks for us, and now we can talk about what they are doing exactly. So we, as we mentioned before, we were talking about the difference between the classic. I call it classical, but it's probably not the term. The regular algorithms and these machine learning algorithms. So why are they more computing intensive?
Yeah, this is interesting because some of the classical algorithm are even more computing intensive of machine learning algorithm. But for sure, modern machine learning algorithm like transformers and which is the fundamentals algorithm on which generative AI is based, are really stressful in terms of computational demand. And the main point is the fact that they have to do a lot of computation in terms of multiplication of matrices. This is the task that an algorithm, a machine learning algorithm, do. This is the very basic task that it has to do to work. And this is the main reason why it performs so well in the GPUs, which are the perfect hardware to perform matrix multiplication. The fact that the generative algorithms requires so much time to train, to inference, and so on, is due to the fact that they have to recognize billions of features in some input data. For doing this, it requires to do an exponential number of multiplications of the different input data, and for this reason you need a lot of computational power, and for this reason we see some interesting things like these days we see, for example, one of the main discussed model, which is SORA, this great model that can generate video from text. Okay, but under the hood, to train this model, you require pretty much an infinite amount of computational power. And for how these algorithms are designed, the main difference between a result or another result is just related to the training time. More features, more inputs data a model has in input, better will be the performance. So I'm pretty much sure that at the moment the main difference between, for example, an open source and a closed source solution is the possibility to run on large cluster and have a huge amount of computational time.
This is a perfect segue for another topic, which is business, because of course, if everything is the way that it looks like, it looks like every company, regardless of their area of influence or sector, is going to have to implement at some level artificial intelligence in order to stay competitive, right?
Yeah.
So, given that everything you have to do has to go through computational power. My question is it feasible to be competitive or stay competitive or try to develop an innovative idea if at the end of the day, regardless of what your idea is, you will need a lot of computing power and hence a lot of money to develop? What do you think? Is it feasible? Is it are we moving into like some sort of huge monopoly of libraries or applications that cannot be, contrasted with your own applications because simply you don't have this infinitive computing power?
This is, I think, one of the a billion question. I mean, it's very difficult to answer because there is no answer, no certain answer. Because the main point is that we have to see how the research change in the next month and years. For example, there is something encouraging, in my opinion, that how these algorithms are changing. I mean, at the moment, for sure, the answer is yes, in my opinion. For the next 3-4 years, I'm sure that the monopoly is on the large company, because for sure they have the possibility to run on a large cluster and have a lot of computational power. But what is interesting is that the research is moving fast, and there are a lot of new application mathematical tricks that gives you the possibility to, for example, inject something in these large neural networks and change some behavior. So if we continue to study in this direction and move in this direction, possibly this algorithm will change and becomes more feasible and more scalable, possibly, to run also on cheaper hardware. And in parallel, if we move also the research in new hardware, much more affordable and more custom for machine learning tasks, the sum of these two things probably will end up in a more equity machine learning distribution, and not just on big companies.
Okay, so so there's hope. You're saying there's hope.
Yeah, I'm really trustful on the future.
Because, for example, and this is an example that touches me directly, because we are doing some tools to create to apply technologies that are, because this is something that maybe the audiences don't know, but once you get inside this this sector, you realize that what is being marketed a lot of times as some things that are completely magical, etc., are actually research that are open for everybody, and everybody can actually use it and apply it. Of course, not full scale, but you can do a lot of things with the papers and the code examples and the models that are open source and available. And there's this phenomenon called like boxing libraries, where you just get an interface that gives the service that is pretty much free, because you could run it on your own, but instead you're being charged for pretty much the handshaking, right? So what I'm noticing is that this, for example, for creating video, it's a hugely computational intensive, and and for example, there's two models right now. One is, you already mentioned it, which is SORA, which is the closed source model from OpenAI. And then there's, for example, it's an open source counterpart that looks a lot less performant, but it's available and you can actually use it, which is called Stable Diffusion Video. And trying them, you see that it takes a lot of time and a lot of GPUs to get results. And the question is, how is it possible that services like OpenAI can give these services for so cheap when if you actually have to pay for the computing power, it costs a lot of money?
Yeah, this is interesting, and permit me to make some point on the discussion, because it's different, the computational demand between training and the inference. And this is the selling point, in my opinion, because the training is the hardest part. I mean, it was the main part in which an algorithm should do this huge amount of computations. Instead, the inference is much more affordable, and it is the part in which you can make more tricks to reduce the computational times. So for sure, companies like OpenAI optimize the inference of their model, and this gives the possibility to make them make the cost of the APIs so cheap. So yeah, I think that is the main point, because otherwise, I mean, it's very difficult try to figure out how generate a video could take just a few cents. I mean, yeah.
Do you think it will cost just a few cents, or do you think that if and when, I don't know what's going to happen, but when SORA is available for the public, it will be kind of an expensive service?
I think that probably, as the other services provided by OpenAI, it will have a very detailed pricing. So in terms of, for example, frame rate, duration, number of token that you can send, so the length of the prompt, for example. But yeah, for a short video, probably with bad resolution, I can say that, yeah, some cents could be a reasonable amount of money.
All right. Right now we're paying a lot more for generating video.
Yeah, but I mean, better resolution and very short.
We have a lot more. We have a lot more control as well. So
that is a very important point that I highlight very much. That is, yeah, these models are fantastic. I mean, incredible. But I think that it's important to consider that you have no control on the result, and if you want to change a small detail in the result, it's not so easy, because you have to redo the inference, and the result will be different from the previous one, also on another kind of details of the result. So yeah, I think that this aspect of uncertainty will be the drawback of these incredible models.
What do you think? Let's talk a little bit about sustainability, right? Because we in this project called Asimov Media that you are actually watching right now or listening if you're on Spotify, there's this the focus of this podcast is talking about, the sustainable development goals of the UN, which is a framework to define what should we do to not, go extinct in the next 30, 40 years. So in this sense, this presents a challenge in terms of course, computational power means more electricity, more energy, more water to cool servers, etc.
Yeah.
So we are kind of stressing a lot the system pretty much, and something just to not be bleak or anything, because the outcomes, the interesting paradox about these technologies that it could solve very complex issues, right? So without going macro scale and going to into the little person, what can we suggest people to do or not to do? For example, to be more conscious environmentally. For example, not doing an inference to open the fridge, for example.
Yeah, this is a very good point. I mean, a lot of these models are used for useless tasks, just for fun or just for see how they works. But due to the fact that they are really demanding in terms of power, will be better use them with more consciousness. So I think that most of the task that we demand on these models could be done in another sustainable way, and a lot of services that are rising. For example, one of the main selling market is of this model is the generation of images, for example, and generate images is very demanding, and I see on internet an infinite amount of websites and services that generate images, and not only the generation of these images is demanding, but especially the storage of and indexation of these images is demanding. So this is make an impact. All the chain has an impact. So not only the generation, but the storage and the retrieval of these media created. So I think that one possible aspect is, as any other tool, is use them with a little bit of more consciousness. So if you have to generate just 100 of images just to generate them, you can probably generate just one image and not 100 to see some different little details, because if you multiply this approach by 1 million of people, it becomes really, really impressive in terms of computational demand and power energy and so on and so forth. So a little bit of more consciousness when you use this.
Yeah, let's go for it. Okay, wrapping it up a little bit. What do you consider are the most? Let's go to the macro now instead. Since you are actually working probably on projects that have a huge impact on on people's lives. For example, when it's about healthcare or for example the industry. What is the silver lining here? Like, what are the applications that you see that can actually improve people's lives and are auspicable to be done with this type of technology?
Yeah, I think that this technology are great for an aspect, which is the fact that it can accelerate the process of doing something. One of the technology I I found most interesting is the retrieval augmented generation, which is RAG for the context. And so it is one of the newest technology which merge together the generative aspects of the models and the local data you have and the data you have, and blending them together gives you the possibility to make the tasks that you have to do more easily, more easy, but also you can do it in a fewer time. For example, let me do an example. You have to read 20, 30 papers in PDF, and you have to summarize them, create some slides, and so on. This is quite boring task and sometimes also time demanding task. So using a technology like this, you can do it in probably half of the time or even in a small amount of time. So why? Because you can ask to a generative model to help you to elaborate these documents without the cost of train the model with this document. So it's no longer need to show at the model the data, but the data are shown during the inference and during the creation, during the generation phase. And this is extremely interesting because you reduce you have no time to spend in training or the other stuff, but you can immediately use the model for your own task and not for tasks that other people had think about. So in general, when you train a model, you focus that model will do a specific task. With this approach, you can use a model for many different tasks, many different usage. You can generate answers for biomedical research papers, for agricultural research paper. You can ask to comment an image and extract information from an image. You can extract information from a video, from an audio, and collect all this information together to elaborate something new. And this is extremely impactful, in my opinion, and useful. And this is the real usage I can see with this kind of models.
Is this kind of technology the one that projects like LangChain are using?
Yeah, exactly. LangChain is one of the most used framework to build RAGs, but you don't need to use them. You can realize the RAGs also by your own. I mean, what is interesting is the logic to build this application, which is a very interesting trick because you, in a certain sense, inject your data during the generation phase. The model, during its generation, retrieve the most interesting, the most relevant information in your data to generate the response. And this approach is a game changer, in my opinion, in the usage of the generation models, the generative models.
What about because you talked about the inference and the training and the difficulty of training. Talking also about the evolution of business, is that we're moving from a model that was used to call the SaaS, software as a service, and to a model that is not, well, software as a service was originally, of course, without the maintenance, but let's say that you develop an app that solved the problem. You did the code once, and then you just pretty much cashed
Get
for
revenue.
endlessly,
Exactly.
and And that's the explanation why people like Jeff Bezos or Mark Zuckerberg became billionaires, right? But now the training is becoming a manual process, which means that you have to continuously put manual work into these solutions. So are there technologies that are helping in the selecting of data, pruning of data, and making this process, which is very manual, a little bit easier?
Yeah. There are many different tools for data labeling, for example, data pre-processing, and so on. But one of the interesting aspects in preparing data for training is the fact that if your data have a bias or an error or something else, that then the model propagate this error in its logic. I mean, so this will remain in the model forever, and this is very interesting in my opinion, because at the end of the day, the performances and the efficiency of a model always start with the purity of the initial data, and not just the purity, but also the how much the data are realistic and representative. We saw many cases in which data are some kind of data are under representative, and for this reason the response of the model is always biased and respond with just one group of data and not the other one. So we can use tools to improve the data preparation and cleaning and so on, but at the end, I think that the manual process is necessary, because we are the final users of these models. So we have to feed them with the data that we want to see also at the end of the process. There is some examples in which, for example, you use a model to feed another model. So you can use GPT to generate text labeled with some labels, and use this data as a data set to train another language model. You are, for example, in this case, what you are doing is give at ChatGPT the possibility to introduce some bias in the new model. So when you will use this new model, you can encounter some biases, and you are not able to make the inverse process. So you see this bias, and you can propagate in the future this bias. And in my opinion, this is a problem. You have always to have the control of the flow, also in this complex model. So and you can have the control knowing which are the initial data.
So yeah, there's a funny example with Gemini right now, which they ask who did more harm, if Hitler or Elon Musk, and he's like,
exactly.
The answer, it's a difficult question, and
so this is an example. Yeah.
So training is a very delicate aspect of the process, pretty much.
Yeah.
And it's also kind of dangerous, because when the expectations of people when doing an inference, which is nothing else than asking for the most probable result of a statistic, pretty much, right?
Exactly.
it's taken by people like an oracle, right? Like, oh, this thing has all the answers, and
Exactly.
it can help with my life or whatever. So it is a bit dangerous to to forget that we as people are actually telling the machine what to say
Yeah.
in some way, right?
Yeah, it's dangerous also because I think that is dangerous taking as true every news that you read on internet. So imagine that this fake news, for example, is used to feed the model, and then after a Bayesian process, so a statistical process, this news is used to generate the answer of the answer at your question. And yeah, so you create a chain of uh, of things that are not real, but if you trust without any doubt, yeah, you have a problem.
My God. So what's the perfect team to create a data set? Like what people should be hands-on into the data set? Because
Yeah.
only data scientists, or maybe philosophers, or what do you think?
Yeah, data preparation, in my opinion, is one of the most relevant aspects when you are approaching to create a machine learning solution. For sure, is not just upon a data scientist, because a data scientist has not all the knowledge of the domain knowledge of each aspect, clearly. So, for example, if you have to create a data set for a biomedical task, for sure you need someone that is a domain expert that can help you to understand which kind of data are good, which kind of data should be labeled in a certain manner, and so on. Because as a data scientist, you have just the statistical tools to evaluate the data set. But without the domain knowledge, you cannot identify some aspects of the data that are further that are beyond the statistical analysis. I mean, so you need for sure the domain expert, and why not? Sometimes a philosopher could be a very good help.
It's interesting because this paradox is probably the most important one when talking about job replacements, right? Like there's a lot of talking about it will replace our jobs, which is a lot of times there's a component of truth on it, because it looks like for people that it's not in the domain that the on the first impression that the LLMs can perform tasks with a lot of competence, and also the data shows it, right? But also there's correct me if I'm wrong, but this is an opinion. Probably there will come a storm of layoffs and people losing their jobs, because it looks like the GPT or the LLM or the tool can do what the person is doing, but then you have this paradox that you actually need a domain expert to validate the results of the tool. So there will be even a bigger need of humans to be on the loop of these technologies, right?
And also another aspect is relevant, in my opinion, that the fact that products generated by this kind of models is not perfect, and sometimes you want to change some small aspects, some tune, the response. And doing this sometimes is very painful, just by prompting and trying to optimize the way you ask something to this model. And sometimes I find more time saving do it by your own, not asking to the model to generate a short email, but probably sometimes if you write by your own, it's better. And this is extremely relevant, for example, for the code. There are many different models that generate code for you by asking generate a function that doing blah blah blah. But it's very, very dangerous, and trust the code that a model generates for you, in my opinion, is wrong, because no one has the control on that snippet of code, and could be potentially a risk for all the code base. And you need always to read it and document it, because otherwise it is just it is useless if anyone knows what this function, this class, this module do in your code base. So in my opinion, the job replacement is a wrong consequence of this advent of this model. This model should be used as a tool, as any other tool, to doing the job, not substitute people that doing the job.
Exactly. Let's do a little bit of futurism to finish the meeting. Right now, Sam Altman has announced that he wants to create start with the building of GPUs business. And the NVIDIA CEO is trying to get into the LLM business. What do you think that will happen? And do you think who will win and who has better chances?
NVIDIA has more historical, knowledge about GPUs, and for sure they are the right choice if I have to bet between OpenAI and NVIDIA. But in my heart, I hope that someone else will come and with another idea, which is not new GPUs, but with new hardware, much more friendly for the nature, for the footprint. And we will see more hardware for machine learning tasks, more affordable, with low computer power, need of energy power, and this is my hope.
Do you think that non-AI development will continue to strive? Will it be guided by AI, or are we going to depend on inferences for the rest of our lives?
The point is that it's very comfortable using the AI. So I think, we depend in future. We will depend even more on the AI, but it is not bad in my view. If we use it just as a tool, as any other thing that we use, it has no problem. The problem is, as we said before, we trust without any doubt on the AI says or write or generate. That is the problem.
Great. Okay, Marco, thank you very much for this. Do you have something else to add? Or something that I'm starting to do is if you could bring someone here, who will you bring, and what would you like to talk about?
Yeah, I think that a good boy could be Sam Altman and ask you, please make more affordable hardware, not another kind of GPUs.
Okay, great. Do you want to add something that maybe you want to specify, something that we missed?
No, I think that we have covered mostly all the topics that we have touched. So I think we are done.
Fantastic. Thank you very much again for being here, and thank you all for listening. You can find this podcast in video format on video.asimov.media, or you can find it in Spotify if you look for Asimov Perspectives. Thank you once again, and I hope to see you soon with another episode of Perspectives. Bye-bye.
Bye.